Um, I like it a lot, and I've been using it on a few projects. I am not personally affiliated with any of the RavenDB developers. I do know the one person behind this company, or an Annie, and we've met before, we're friends, but other than that, I'm not trying to sell you on RavenDB. I'd really like to just tell you about it, show you some nice code, and then you'll be able to decide for yourself, because there's a bunch of options for NoSQL databases today, and even for the specific niche of document databases, there's a bunch of options that you can explore. So that's just a disclaimer before we get started. My name is Sasha Goldshtein. I work for an Israeli training and consulting company called Sela. If you have any questions, then just please feel free to ask and interrupt. It's fine, we're used to it in Israel. And you can also follow me on my blog and Twitter if you'd like to read more about what I'm doing. I have a bunch of talks at DevWeek, and this is the one before last, I think, this year. Next one's after lunch, and it's on the direction.net is going, the open source.net announcements and all that. Hope to see some of you there as well. So RavenDB, the .NET NoSQL database, and even though NoSQL has been around for a while, I just want a couple of slides just to give you a very, very quick idea of what we're talking about, so that we're all on the same page. Clicker's not working. Yes. So lots of people sort of define NoSQL in a negative way. NoSQL is not SQL, so it doesn't use SQL. It is not as consistent as an RDBMS, as a relational database. It doesn't always offer ACID semantics, atomicity, consistency, isolation, durability. It doesn't put as much of an emphasis on relations between entities. So often you wouldn't be doing joins a lot. You'd be using some other way of reading related and associated data. And generally, it emphasizes size and scale over structure and schema and this rigorous modeling of relationships and normalization. But that's all just really a very general characterization of NoSQL. And it is in fact very general, because there are at least 4 major families of NoSQL databases available. And this characterization is also very old. Hopefully some of you have seen it before, but this just helps to understand where exactly we're focusing, what exactly we're focusing on. So document databases is the family that RavenDB is part of, and also databases like Couchbase Server, MongoDB, which also was represented at this conference. So there's a bunch of options in the document database space, and the idea there is that you model your data as a set of documents. And you usually index those documents so you can make fast queries, but relationships between documents are not as much emphasized as, again, relations in a relational database. Specifically, MongoDB and also Raven use JSON for the document storage. It means every entity you store in the database is eventually serialized to JSON, but of course it can be stored in a more efficient way, space-wise, than just text JSON. So it doesn't mean the database is wasteful in terms of space. Column databases is another big family. For example, Azure Table Storage is in fact a column database, ColumnDB. It's more or less like tables, but again, unlike a relational database, there's not as much focus and emphasis on relations between tables. It's mostly just about representing your data as a set of rows and columns. And the columns you have in each row can be dynamic. So some rows may have more columns than others, which usually doesn't happen in a relational database. Then we have key-value stores, key-value databases, which often overlap a lot with document databases. In a key-value store, every document has a key. Every value you store has a key, but the values can be arbitrarily complex usually. So you can look at a document database as a kind of key-value store, or the other way around. Again, there's lots of overlap. And finally, graph databases are a somewhat different beast altogether. For example, Neo4j, which is also useful from .NET, is a pretty popular graph database. It's a UK company, by the way. And so graph databases usually represent data as nodes, and the relationships are quite important. So there are edges in the graph between nodes, and the queries and the structure of the way you store your data is really dictated by the nodes and edges. So that's just, kind of a very, very, very brief overview of NoSQL solutions, because I'm not trying to give you an overview of NoSQL here, just sort of to focus on what we're going to be discussing. And that's Raven, which is clearly, classically, a document database, which pretty much directly competes with databases like Couchbase and Mongo. So just to tell you a little about Raven before we start digging in, exploring the APIs, and writing some code. RavenDB was created by this gentleman here, Orenani, who goes online by the pseudonym Ayende Rahien. He's Israeli, just like me. I don't know how he came up with that, but his name is Orenani. He's a really nice guy, and he now has a company, so it's not a one-man product, a company called Hibernating Rhinos, which is behind RavenDB and a bunch of additional very nice developer tools like database profilers and a bunch of others. So Oren started Raven as pretty much a personal side project. And I mean, not many of us would build a NoSQL database as a side project, but then today it is a really popular offering. It doesn't have, the huge popularity of MongoDB, for example, but it's pretty popular in certain circles, and it's a really nice database to work with. For .NET developers, the good news is it has a link-style .NET API, which is very mature and it's first class. So the database has been designed for .NET clients, for .NET consumption. So if you're doing C# or VB, you'll find it very, very easy to use link, same way as you're probably using Entity Framework or Link to SQL. You'll find yourself at home with Raven from that perspective. The database itself, the product I mean, is open source, and it's on GitHub, and you can use it in open source non-commercial projects for free. If you plan to use it in a commercial project, then there's licensing costs per server, and I refer you to them to figure it out. But you can definitely get started, try it out, use it for your personal non-commercial website and stuff like that, usually for free. And for open source project, they have a nice licensing scheme as well. The database is schemaless, so again, unlike a relational database, it doesn't impose a very strict schema on your documents. So you can just basically grab an arbitrary piece of JSON and just shove it into the database, and it will definitely work and be stored and indexed. However, if you're doing .NET anyway, then you probably have classes representing your business entities, and so there probably is already some kind of schema. So you already have, say, order objects and customer objects and line item objects and product objects. And if they can be serialized to JSON, then it's really likely that you can put them in the database. Question is how exactly you're going to design your documents, and we're going to talk about that for a few minutes later. What kind of options are there, how to make sure your documents aren't too big or too small, how to make sure you don't query too much. So we're going to address these issues a bit later. Raven, even though it has a very nice .NET API, has REST endpoints for all the operations. So basically the .NET API is to some extent just a wrapper on top of HTTP calls. It does have additional features like cache, for example, on the client side, but all server communication is through HTTP, which means there are unofficial clients for Raven in other languages as well. And you can, use Fiddler to query the database if you prefer. And recently, Raven also supports Java. So there is a first-class official client SDK for Java applications, which you can use alongside the .NET one. Finally, there is a really, really nice feature about Raven, which is pretty unique in document databases, and that's implicit indexing. And we're going to take a look at indexes a bit later, but just to give you a very quick idea. Say you have this huge database, a lump of documents in it. They have some kind of schema, maybe some documents are like others, some aren't, and you want to make efficient queries. Obviously, just searching through all the documents you have, looking for particular data in them, isn't going to be very efficient. So every document database has some kind of support for indexing. It will take your documents as you insert them to the database, as you make changes and so on, and it will try to index them in some way to make searching, to make queries efficient. Raven does this implicitly. So whenever you do a query, we'll see an index is generated for you. So the first time the query is going to be slow, but once you run a query, there will be an index that will make this query faster the next time. And in many cases, for many kinds of applications, you can make do just with these auto-generated indexes, the ones the database just sort of fills in for you as it sees the queries you're running. And this is unparalleled in the relational world, where you have to spend lots of time with your DBA building the right indexes for your tables, but it's also pretty nice for the NoSQL world, where you usually have to think about indexes up front. And in Raven, you often don't. We will also see how to define custom indexes which are explicit, but the implicit ones are going to be very nice as well. And finally, one other nice thing I really like about Raven is that it has very powerful full-text search built in. There's an analysis engine built on Lucene, which is a pretty popular open source product for full-text search. And it has support for a bunch of different languages as well. It's open source, very active community, rapid release rate. And Raven gives you the Lucene engine for free, basically, as part of the product. So you can do full-text searches, very complex ones, with query suggestions and similar features. And I'm going to show you a quick demo of this towards the end of the session. It's a really great feature to add if you have any kind of search support in your application. Okay, so let's start with the basics. How do you run this thing? How do you host this thing? What is the deployment model, really? So if you download Raven from the official website, what you get basically is this Raven folder, which has a bunch of files in it and a bunch of folders in it. You get documentation and samples, and you get a server directory, which has a bunch of files that can be used to run the server. There's multiple hosting options available. You can run it as a console application, raven.server.exe. Let me just quickly run it for you. There's a batch file that ships with Raven that will run the server for you in a separate window, and also open a web browser and navigate to the management console, which we'll look at later. But basically, as you can see, it's hosted in a console app now, and it prints out a log to the console of every request you make to the database. And the management studio in the browser made some requests, so we can see them here. This is obviously very, very convenient for development, but not so much for production use. So you can also host Raven as a Windows service. You can host Raven in IIS. It's just an HTTP server, after all. And in the recent versions of Raven, it was also built on top of Web API. It used to be a custom HTTP listener. It's now built on top of Web API. There's also an embedded client if you're not planning to have a server at all. If you just want a database to be used as part of a standalone application, there is an embedded client which doesn't require any hosting, no external processes, nothing. You just access files on disk locally. And there are a couple of cloud hosting solutions. So obviously you can take Raven and put it in a virtual machine on Amazon. But there is also at least one provider, Raven HQ, which will host a Raven instance for you. So you pay them to manage your Raven instance. You don't have to deal with updates and deployment and scale and so on. So there's a bunch of options for hosting. And once you have the server running, you can start making HTTP calls to it. Again, you don't need any .NET client, Java client. You can make simple HTTP requests. But there is also a really nice management studio, which I'd like to show you now. In Raven 2.x, it was Silverlight based. And we all know what happened. I hope we all know where Silverlight went, to the place you don't come back from. And in Raven 3.0, the management studio has been redesigned and rewritten in HTML5. So it works on all platforms, it works on iPads, and so on. I'm still using the previous version, so here's what the management studio looks like. Here it is in Firefox. Silverlight application works really well, where you have Silverlight support still. And let's just take a look at this. So there is a set of documents And I have multiple schemas of documents here. The application I've built, and I'll show you in the demos, is a conference management application. So you have conferences and speakers in tracks, and you have talks by those speakers, and you can search this stuff. So we'll see what it looks like soon. And in the Management Studio, you can see the structure of your database. You can look at individual documents if you'd like. So let's say here's a document. And as you can't see, but I will zoom in, as you can see now, it's just JSON. And this is a session by a fellow speaker, Ido, who lives in Rehovot and has 20 years of experience. And here's the ID of that speaker document. And here's also the session description for his ASP.NET session. So again, it's just JSON, and there's obviously support for collections and so on. We'll see somewhat more sophisticated documents later. In the Management Studio, there's also support for running simple queries. So say you want to, like you do in SQL Management Studio maybe, run a couple of queries on your database, find all the speakers, whatever. So I can pick an index and then query all speakers whose name starts with Sasha. I'll show you the query syntax a bit later. Or maybe just all the speakers we have in this particular database. And there is an indexes section in the Management Studio, which we will also be spending a little time on. And we'll see that some of these indexes are generated by the database as we make queries. And some of those indexes we created to make certain operations work even faster or to give us full text support. So the Management Studio is a really nice tool. It also has lots of performance information on your database's behavior. The number of operations you run, index performance, overall load on the database, errors, logs. It's all available in the Management Studio. And generally speaking, in terms of diagnostics, Raven has a bunch of really nice options. There's performance counters, lots of logs, the Management Studio integration, a bunch of statistics. It's something that was really well thought out and is based on a lot of experience with troubleshooting really nasty issues at customer sites. Okay, so that's the Management Studio, and let's start talking about the APIs. How do you use this thing? How do you put documents in it? How do you query? And so on. So the first key concept you have to be aware of is the document store. The document store is kind of your one main singleton object for accessing the database. You create one of those per application. For example, if you're doing ASP.NET, you don't need one per request. You don't need one per user. You just need one of those document stores to connect to the database. And you can use standard connection strings to use a document store, or you can just explicitly say where your database is, which database you want to access on that particular server. There's a bunch of properties on document store that you can use. Once you have the document store, you use it to create sessions and then run operations against the database. So here's one simple example of a console application I used to populate this conference's database. And yeah, I realize I shouldn't have done it in code, but I have a bunch of objects in code which I'm then storing into the database. So over here, I'm initializing a document store, and then I'm opening a session with that document store. And this is your unit of work. If you're using, say, Entity Framework, this is your DB context. This is the thing you work with and then dispose at the end of your session, of your request handling, what have you. So in that session, I create a bunch of objects, and these are just plain old objects, yes? So if I go to the speaker class, here's the speaker class. No special attributes, annotations whatsoever. I realize in recent versions of Entity Framework you also don't need any annotations, but it used to be the case that you need a bunch of attributes and XML files and stuff. In Raven, it was always just plain classes, and as long as they can be serialized to JSON, you can put them in the database directly. And of course, again, collections and all stuff like that are supported. So I create a few speaker objects, and then I store these speakers in the database. And then I create a few sessions, and there are relationships from sessions to speakers. So the session object over here simply has an embedded reference to the speaker, and that's, again, perfectly fine. The relationship is understood by Raven. Multi-relationships are also supported, so I could have a session have multiple speakers if I wanted to. So I create a bunch of sessions, and I store the sessions in the database as well. But by the way, we'll see exactly what it means for the session object to embed the speaker as opposed to having a reference to a speaker. We'll talk about that. We'll see some examples. And then I have a bunch of conferences. And a conference is a more complex object. A conference has a name and a year. It has a collection of speakers, and it also has a collection of tracks. And tracks have titles and session IDs. So the sessions aren't embedded in the tracks which are embedded in the conference. Instead, the tracks have references to sessions. And this is the kind of design decision you have to think about when modeling your schema, modeling your database, your document store, and we'll discuss this kind of thing in a moment. So having stored a few conferences, at the end of the whole process, we call save changes, which is kind of like submit changes in other ORMs. And the objects are stored. Making patches, partial updates, and so on, of course, is also supported. So you could query an object, modify a property, call save changes, goes into the database. I realize some of it is obvious, but it's important to make note of what just works. You know, out of the box, no additional cleverness required. So that was the little console app that builds our database. Now let's talk about making queries. Okay, so the store example over here we saw in Visual Studio just a moment ago, but let's talk about simple queries. So this is LINQ at its finest. If you have a session, you can just do session query, and you say which kind of document you'd like to retrieve, because at the end it's a document database and you are getting back documents, and then just use LINQ. And of course I could use the more familiar language-based LINQ support, but I'm using the method-based support here. So query for speakers where the speaker's city is Jerusalem, and get me the first one, please. Again, LINQ, plain LINQ, just like you'd use with any other .NET ORM. And I can make a change to the speaker's city and save the changes, and again, it's propagated to the database, no additional effort required. All right, next up, a few words about collections, IDs, and operations on those. So documents, like I said, are stored in JSON format. Everything you put in the database is serialized to JSON, but since you're not really just storing arbitrary blobs of JSON, since you really have objects in your .NET application, the Raven database keeps track of which CLR object, of which CLR type is associated with each document. So if you look at an individual document, at an individual JSON document in the Management Studio, for example, you'll see a property that indicates where it's coming from. So if I go to, say, Documents, Sessions, and pick a session, you can see on the left-hand side, there's metadata for the document, and one of the pieces of information I have here is the Raven CLR type. And this is the fully qualified type name for the .NET type you used to store this entity. A collection in Raven is then just a set of documents that have the same type. And again, it's really useful to model it in that fashion. So I have a speakers collection and a conferences collection and a sessions collection. But tracks, they aren't standalone objects, as you recall, so there is no tracks collection. They're just part of a conference. Documents have unique IDs, and this is often, by default in fact, formed as the collection name followed by the document ID within that collection. But this whole thing is the ID, and it's somewhat more useful than GUIDs. There is an underlying GUID somewhere, but this is more useful, obviously. Even reading it over the telephone is more useful. So now let's talk a little about modeling data as documents, what should be a document, what should be just embedded in another document, through a set of examples. And these aren't examples specific to RavenDB. This would apply if you're using Mongo. This would apply if you're using Couchbase. You always have to think, when you're building your schema, what kinds of documents you have and what relationships you have between them. So here's one example which you already saw. We have a conference object. We have a conference document, and in a conference we have tracks. And tracks have a title and a list of sessions, but these aren't session objects, they are session IDs. So there's a couple of design decisions here that we have to think about. For example, should the tracks themselves be individual documents, and then the conference would just have IDs for tracks and not the whole track document in it? Question 2, should sessions be individual documents, or should they also be embedded in the track document, which is embedded in the conference document? So which things here should or shouldn't be standalone? And there are some key rules, but it's generally also a matter of common sense. So for example, you often shouldn't be normalizing everything like you would in a relational database. So it doesn't always make sense to have a document for a track, and a document for a session, and a document for a speaker, and a document for the track title, and so on and so forth. It often makes sense in a document DB to duplicate some information just because it makes it faster to access that information, because it is accessed together and modified together. So you shouldn't fear denormalization as much as you would in a relational database. It has a much lower cost. So yeah.
You said duplication of data is fine, but when it's come to updating an object, would that be a problem?
Yeah, so that's exactly a good question of when things change and whether they change together or not. So in this particular example of conferences and tracks, what I wanted to do now is ask you what kind of options you'd think would make sense. So let's address the tracks thing first. So should tracks be references to external documents representing a track, or can we just put the track documents here as part of the conference document and that's it? So can you give me a convincing reason for splitting out the tracks into separate documents?
For the reason of modifying each track, maybe it's better to split them.
Okay, so you're saying that tracks can change independently of the conference?
Maybe.
Maybe. But that's a good question. I mean, I don't know. Maybe in your design they would, maybe in mine they wouldn't. The way I model this database is, the way I think about this database is, the conference organizer creates the conference and creates the tracks and populates them with sessions, and then there's very little changes. So tracks don't change individually. There is no track management. There is management of the whole conference. And in general, once this whole thing is populated, there are very, very little changes to the structure. They could be, for example, in my design, maybe they could be changes to the descriptions of individual sessions. So I don't want the session description to be part of this document. But there are rarely changes to the general structure of things, so to the, I don't know, sessions of a particular track. I'm not saying this is the right design. I'm just saying that when I'm when I'm making certain assumptions about the way I'm going to use the kind of operations I'm going to make, that should dictate the structure. Let's take a look at a couple more examples which are somewhat more interesting. So suppose I want to model my blog as documents in Raven. So is this a reasonable document? I have a blog document which has tags, and then it has posts. And the posts are just, posts. So I have a title, and I have content for that blog post, the whole HTML thing, author. And I also have comments, which are all the comments people had to make on each individual post. And my blog has 500 posts. So what do you think about this nice little document?
Every post should be a reference.
Yeah, so this looks like a way too big to be a document, to be one document. Because, for example, whenever I write a new post, or even when someone posts a new comment, we'd have to update this whole thing. Now, Raven does have support for patching. So you don't have to necessarily load the whole document, transfer it over the wire, make an update, and then transfer the whole thing back over the wire. There is support for patches, but it definitely is easier to design the thing correctly in the first place instead of using patches. And so here, probably a post should be a separate document. And then adding a post to a blog does require updating the blog document, but it's only a small update, and the whole post document is stored separately. Plus, the comments, if I store comments inline as part of a post, I can add a comment to one post, and it doesn't affect another post, obviously. Now, whether comments should be individual documents is also an interesting question, and the answer depends on how many comments I'm going to have, how big they are, if there's reason to change a particular comment after it's been posted, and so on and so forth. Again, it's not specific to Raven. You're going to have the same issues when designing any kind of document store. And obviously, you could go all the way and just have one huge document, which gives you nothing. Or you could go all the way and do like you do in SQL Server or any other relational database. And then every enum has its own little table. And DBAs really like this kind of design. It makes them feel elegant, but it's not always worth the extra effort in a document store. And finally, a last example, which again emphasizes usage. So over here, I have an order document. And an order has basic customer details embedded in it. I have the customer name and an ID. Now, I could just use the ID to get the name, but that would require another hop to another document. So I store the name in line. And then the order has line items, and these are products, costs, and quantities. So this could make a reasonable document. There's not too much duplication here. The customer details, for example, are stored separately. But here's one question. Suppose whenever you query the database for an order, you always need the customer's address. This is the way your application is built. Whenever an order is displayed, you always need the customer's address to be displayed right next to it. So again, it doesn't go well with normalization, but it would make sense in that case to just put the customer's address in that document. If you're going to read it anyway, every time you read an order, you could just put the customer's address in there. That's assuming the customer address doesn't change often. What happens if it does change often? Yeah. Then exactly. Then we go back and we'd have to update, whenever the address changes, we'd have to update every order made by that customer to have the new address, and that, could mean lots of unnecessary work. So this is the trade-off again. Do we always need the address? Are we going to make changes to the address often? Is it just a one-time thing that the address changes, right? And one other example, what if we always need to know if the product is in stock? So whenever we query an order, we have to display also the information on inventory, whether the product is in stock or not. You'll notice the current design doesn't have product IDs or anything. It just has basic information about the product, which is useful for displaying order details, but it doesn't have in-stock information. So what do you say now? Yes?
I'd say probably just stick in the ID, because it's not going to change.
Yeah. Now, hypothetically, I could say, let's just add an in-stock property to each line item. But that obviously doesn't scale, because in-stock status changes all the time, and you'd have to update pretty much every order every time you ship something or cancel an order. That wouldn't scale. But what you're suggesting is just store product IDs, right? So instead of all these details on the product, just store product IDs. So you can make the somewhat expensive but necessary query. Whenever you query an order, you could also make a query to get all the products and their in-stock status and display that. Again, just showing you some of the trade-offs here. We could spend another hour talking about modeling documents in document databases, but let's move on and see some more of Raven's power.
Can I just ask what happens if you have your database and then you make these changes later? So, for example, the author field, previously you want to have more than one author in your talks, but you've already built your database. How do you...
You'd have, yeah, if you make a considerable schema change, then on one hand, you could just keep all your existing documents and use a different type, for example. If you use a different type, then there's no conflict, but it obviously complicates your code a lot. If you do intend to use the same type, you'd have to make an update. You'd have to update existing documents, yes. But then it's a little like making a considerable change to a SQL schema as well. So if you had a design where you just store when you store one author ID, and then suddenly you need to store multiple author IDs in a SQL database, it would require probably making an intermediate table, foreign keys. It's a considerable change anyway. So yeah, it doesn't make it much easier to make this kind of changes. It does make it much easier to add stuff. So if you have a document that's missing some optional fields, that's fine. They're just going to be null. And that is very forwards compatible. But yeah, making a big schema change is painful. Yeah. OK. One other thing that I probably should mention as we discussed normalization and denormalization, that pretty much like Entity Framework, Raven also has support for includes. So you can say when you're going to the database and fetching a particular document, please also fetch related documents, which I'm going to need anyway. And when Raven does that, it will put all these related documents in the session cache. So whenever you make subsequent accesses to these documents, they're available on the client. You don't have to make another server trip to get them. So for example, over here, I can say session include order. When you're fetching an order, then please also fetch the customer specified by the order's customer ID. And then as I load an order and then load the customer, the second load call isn't going to make a database server trip because the customer was already retrieved in the first call. You can also do this for one-to-many relationships. So for example, if an order had multiple products, I could say, when you're fetching the order, also include all the products. And then we're making one round trip to the server. All the documents are returned. My code is only using the order, but as soon as I need the related documents, they will be available. So at this point, I think we can take a brief look at the basic functionality of our little application. So let me just, OK, the server is already running, yes. So I'm just going to run this thing. It's a very simple MVC app that displays conference information. So this year's conference, we have DevWeek with a couple of fake tracks I've put in there. And then on the right, we have speakers with a session count for each speaker. And this is something we'll see requires an index. Some other features we have here, we can take a look at an individual track. And there's sessions in it. And if I click a speaker, I can see speaker details. So really very basic functionality, but does illustrate basic operations. Now, let's take a look first at the index for the home controller, which displays this basic page. It just shows you a couple of simple APIs. So first, we have a query over here to display this year's conferences. I take the Raven session, which is a per session object created elsewhere, per request object, I mean. We query conferences where the year is the current year, and I materialize this to a list and then pass it to my view. The second query here uses an index, and we'll see that it explicitly specifies the index to use, and this is the speaker session counts. And I'm also asking for an order by so that we sort the output by session count. Both of these things are then, like I said, passed to the view. Here's another example which loads an object from the database by ID. So if you already have the object's ID, and in some cases I do, then I can just ask the session to load an object by the object's ID. This is the cheapest way to retrieve an object from the database. It's an immediate index from the document ID to the object. And one other example in speaker by name, well, that's pretty much the same actually. And oh yeah, I have one with the load and include that I wanted to show you. There. So here we have a conference ID and a track. And we need all the sessions for that conference and track. So I include for a conference all the tracks and all the session IDs specifically. The tracks are part of the conference object anyway, but the sessions aren't. We have references to the sessions. So when you query when you return conferences from the server, then please also include any sessions in any tracks. And then I load the conference by ID. And then I only need sessions from that particular conference from the specific track I was asked for. And this is what this query does. And it will not make another server round trip because we already included all the sessions when making this load over here. So just one trip to the server. Now the really cool part, and again, there is similar functionality for MVC, for NT-Framework as well today. Raven has a built-in database profiler which you can use to see just how many server round trips you're making to the database backend, that is. So for example, if I refresh this page and I go to the RavenDB profiler right over there, it tells me just how much time exactly I spent waiting for the database server and which specific requests I made. So there's a couple of them here. One is a request for this URL, databases, conferences, indexes, dynamic conferences, and we'll see what it means for it to be a dynamic index. And the second uses an explicit index, which was created by code, databases, conferences, indexes, speaker session count index. So these are the only two requests that we're making to the database. We're not making any redundant calls. And similarly, if I go to a particular track, then again, you can see that only a single request was made to fetch the conference and the tracks and the sessions in one database call. And there's also request details here where you can see, if you'd like, the entire result document returned from the server and so on and so forth. So the profiler support is nice. It just helps without a debugger understand what's going on the wire. You obviously should turn it off for production then. OK, so that includes, and I think what we should be talking about next is indexing, because that's a really interesting part of Raven. It's one of the things that make it so unique, this automatic index generation. And it's really interesting to see what Raven can do on its own and what requires some additional tweaking. So first, Raven creates indexes as you run your queries. That's again, a key selling point. You don't have to explicitly think up front, at least in many cases you don't have to, about every single index you'll need, about every single query you're going to run. You can just write your queries and then expect the database to do the right thing, just to generate the indexes for you. And so here's one example. Again, it's in the code we have already reviewed. Over here, I have a query that looks up conferences where the conference year is now. It looks like a really simple query if it was a SQL database, but this isn't a SQL database. There aren't any explicitly generated indexes for conferences. And so the first time I asked this of Raven, it would have to do a linear search. It would have to go over all the conference documents and see if the year is 2015. But the next time I do it, there is already an index mapping years to conferences. And we'll see what indexes look like very soon. In the Management Studio, I can already see this index now. You can see this auto-generated index called auto conferences by year. And if I look at the index statistics, for example, it says over here, there are 3 documents in that index, and there were 9 indexing attempts and 9 indexing successes. This happens whenever there is a change to the conference's document set. And I can also query the index to see all my conferences, but I can also query the index by year and see conferences from that year. So again, it is not a linear search anymore. There is some kind of association between years and documents and conference documents for that year. And it was just created automagically, which is the nice part about these auto-generated indexes. One thing we'll have to talk about in detail soon is that indexing happens in the background in Raven. So it is possible that the stuff you get from an index is not entirely up to date with your database contents. It is possible, for example, that someone made an insert and created another conference in the year 2015, just 5 seconds ago, and my query, made 5 seconds later, would not see that new document yet, because the index hasn't been updated. It is possible in Raven. Even though the indexing process is usually pretty quick to catch up, it is possible that an index will give you stale results. And if that's a problem for you, you can see when making the query, you can get statistics out of the query and see if the index is stale, if it's giving you stale results. And furthermore, you can see how up-to-date it is. So is it 5 seconds behind? Is it 5 hours behind? And then you can make decisions according to that as well. Now, if you think about it, an index that's 1 second behind in this kind of application is probably nothing to worry about. An index that's 5 hours behind is a bigger problem and probably indicates something's pretty wrong with your database. You have control. You can even ask the system to wait until the index is up to date so that you don't get stale results guaranteed. But what I'm trying to say is that you don't usually need this. You can often live with a few seconds, a few minutes of staleness in many kinds of applications, and that's the kind of trade-off you can make between performance and just getting results, between correctness, so to speak, and just getting results as quickly as possible with the little chance that some of them are stale already. Now, and here's the thing we have, yeah.
How does it know that an index is stale?
Yeah, so let's discuss this now. How is this a database if it can't guarantee correctness? How is it a database if it can't give me the right results, right? How is it ACID, really? How does it guarantee atomicity, consistency, isolation, durability if I can get incorrect results from my indexes? So here's the key part to understand. There are two major components to Raven. One's the document store, which only takes care of storing documents, loading documents. And it is ACID. It supports transactions, and it is ACID, so whenever you finish a transaction, the side effects of that transactions, the documents you changed or inserted, are made visible to everyone else atomically. The index store, which you use when making queries based on indexes, is not ACID. It is updated in the background after changes are made to the document store. And usually, these two things are only a couple of seconds not behind each other. So the indexing task really fills in any blanks very quickly. But it is possible if you're making, say, a huge number of inserts, it is possible for the indexing task to fall behind. And then you don't know, the index is stale compared to the most recent changes in the document store. Now, you know whether the index is stale because you know when the most recent changes were made to the document store. So you can tell how far behind you are. And again, it's quite rare that even under load, you'll find yourself more than a few seconds behind. But if it's a critical issue for you, again, the absolute correctness of the data you're reading, then A, you can make, as part of a query, you can request the data to wait for the index, the results to wait for the index, or you can just use the document store directly. If you fetch documents by ID, if you don't need indexes, if you don't use indexes for that query, you always get up-to-date information if you go to the document store directly. Again, that's the trade-off, and you can't say I didn't warn you. There are some, it's a little different than a SQL database. Many NoSQL databases make a similar trade-off. Indexes run in the background, and they are not guaranteed to be up-to-date. But the benefits you get from this in terms of performance are incredible. Just think about making an insert to a SQL table that has a bunch of heavy indexes. As part of making that insert, the index has to be updated. So you can have an individual insert taking many hundreds of milliseconds because it's part of the cost for making the insert operation. You have to make sure the index is fully atomically updated as part of the transaction. Not so in Raven. The insert is instantaneous, and the index, well, it kind of keeps track in the background. So for a moment there, you might not see the new document, or you might not see the change from that index, but you will very soon. That's the trade-off we're making, and it's extremely important to understand that trade-off. For many kinds of applications, it is a reasonable trade-off. Okay. Yes, sir.
Yeah. Is there a way of disabling indexing with Raven?
Disable indexing?
Yeah.
If you don't run any queries, then you don't need any indexes. But for any kind of query, you need an index.
Right. Okay.
Unless you just want to go over all the documents all the time in order, no filtering, no nothing. And that's not so interesting.
Right. So every time you run a query, you create an index. So can you tell Raven that will create an index right there?
Yes, but it means the query would always do a linear search.
Right.
If that's what you want, yes, you can have it that way. Okay. So let's talk briefly about indexing fundamentals and then see some pretty cool examples of creating indexes. So the basic idea is that you have JSON documents in your database, and they do have a certain structure, they do have a certain schema. You can run queries and so on, but you have to tell Raven implicitly or explicitly which properties of these documents are interesting for you, which properties it should build an index for. And an index is just essentially a sort of mapping from sorted field values for the fields you're interested in to documents that have that value. For example, if I have 3 orders over here, I could have an index by customer name. And that index would say, where the customer name is Dave, we got 2 documents, and here are their IDs. And when the customer name is Mike, we have 1 document, and here's the ID. Similarly, for numeric fields, you can also have ranges. And indexes, again, they're built automatically, but you have some control over the kind of indexing that happens. So here, for instance, I could have price range indexes on order objects. And then again, I can easily query for orders in a particular price range. So every field of every document that you plan to query will have implicitly or explicitly this kind of index generated for it. And these indexes are good if you're doing simple queries, if you're matching for greater than, less than, equal to, exactly. If you want full text search, which is another great feature that Raven supports, we'll need somewhat more sophisticated indexes which understand the structure of your text, and we'll see what these indexes look like shortly. Now, the very simplest index that you can imagine is one that just tells Raven, please index this particular field of this particular object. Just build me an index like this one from a certain field value to all the documents that have this field value. Again, Raven's going to do that by default, first time you run the query. But for some reason, you might want to create this kind of simple index yourself as well. For example, to make sure it's there from the onset, from the very moment your database is generated. And so here's how you create this kind of simple index. You tell the session to create a new index with a specific name. The name is arbitrary, but there is a convention for index names. And then you use an object called index definition builder, which is generic in the type of entity that you are indexing. And in it, it has map and reduce functions. In this case, we're only using map to say that, given a speaker, we would like to make an index on the city for that speaker. Now ignore the syntax around this thing. It's really something you can get used to. Key part is it's an index for speakers, and given a speaker, we are selecting that speaker's city. This is the field we would like indexed. The result is that there is some sort of associative structure from all different cities to speakers that have that city, to speakers from that city. Here's a somewhat more sophisticated index, which uses aggregation. And this is the speaker count index. In fact, let me show you this thing in Visual Studio. The home page for our application uses this index. It generates this display on the right where for each speaker, I have a count of sessions. This is something you do with a group by query in SQL, right? Group by, count, something like that. In Raven, it requires a little more work. So let me find the index for you. There it is. OK, so I have a class called speaker session count, which maps a speaker name to the number of sessions that speaker has. And then I have a class derived from abstract index creation task. This is an alternative approach to what the slides suggest. So you can either write a class or you can tell the session that you want to put a new index, same thing. And this speaker session count index class, which derives from abstract index creation class, only has this simple constructor which specifies the map and reduce functions. The map function goes over every session in our session collection and emits a new little intermediate document that has the speaker's name from that session and the number 1 as the session count. These are intermediate documents which will then be reduced, aggregated. If you've ever used a MapReduce framework like Hadoop and similar stuff, it's exactly the same idea. So the map phase generates for each session the speaker and the number 1, and the reduce phase takes all these intermediate objects with speaker name and the number 1 and sums them up so we have the speaker name and the session count. So the number of times we've encountered that speaker name, and they are all summed up. So it's pretty much a classic example of MapReduce. If you look for the word count MapReduce sample, it's basically the same idea as what I'm doing here with speakers. But it does look a little daunting at first, and it's probably more complicated than just writing a group by query by hand. But here's the amazing thing. When you do a group by query, the database does all the work every time you run the query. So whenever I refresh the page, if it was a SQL Server database, for example, the database would have to run the group by query again and again and again. Now, obviously, you can do caching and stuff, but generally, you ask the database, a SQL database, to do a group by, it will go and do the aggregation every time. Here, however, because I've thought about this problem in the first place, the index is updated whenever there is reason for it to change. But generally, if I don't add sessions, if I don't add speakers, if I don't change any of these objects, the index is generated and it remains relevant forever. So whenever I do a query, you don't have to touch any single document. You just look at the index and return whatever the index contains. So there is no aggregation when you query the index, which means the queries are instantaneous. You don't spend any time waiting on the database because it's all there. The index is there. And this is, again, part of the incredible difference between NoSQL databases with indexing like Raven and Mongo and SQL databases when you'd run the query every time. Here you basically have the query's results always available and always up to date. And the cost of updating them is in the background. It's not part of any individual request, which is really cool. So this speaker session count index is probably the most sophisticated one we'll have time for today in terms of index structure. Again, this MapReduce thing is just a way for specifying aggregation. I go over all the session documents, and in 2 steps, I generate this mapping between a speaker and the number of sessions this speaker has. Now, we do have time for full text search, so I'm just going to skip over a couple of slides there. And full text search is an incredible feature that you can use in Raven. And let me maybe first show you what it looks like in our little app. So I have a search tab in this little application, and if I search for a speaker by full name, you won't be surprised that I can find the speaker. But what if I did maybe, well, a typo? The web page says, "Did you mean?" Or what if I just type the letter I? Oh, no matching results. How about Ido? Yeah, okay. And by last name? Also fine. And how about a little typo? Yep, did you mean? And I have the same thing for sessions. So say I say Azure, finds me all the Azure-related sessions. But if I mistype Azure, oh, I didn't put suggestions on the left. Sorry. I only have suggestion support for speakers. Yeah, okay. So it wasn't supposed to find anything, but it's really a 2-line change, as you'll see. So this kind of full text functionality is pretty useful for lots of apps. And you'd really rather spend as little time as possible on supporting this. And so again, Raven just ships out of the box with Lucene, which is a really powerful full-text engine, which is also used by products like Solr, which is a pretty popular full-text search product. Elasticsearch has Lucene foundations. And so all you have to do to enable full-text search for certain fields of your documents is, as part of the index definition class, just add a call to the index method saying which field you want and that you want the field indexing analyzed behavior for that field. This will have Lucene apply its extra full-text indexing magic so that you can make these fuzzy queries on speakers by name or sessions by name or multiple fields of a specific document. So if you have multiple fields, you can try matching against any of them, again, in a fuzzy full-text search fashion. And you can also ask the engine, and again, I'll show you the code for this, you can also ask the engine for suggestions. So let me just show you the relevant code. If we go to home controller, I have search sessions taking a term. And the way I searched both speakers and session titles at once is by using the Lucene query method. So Lucene query of session uses a specific index, the session search index, which I'll show you in a second. And the where clause is not link anymore. It's a string query in Lucene format, which says the title field is one thing followed by an arbitrary string, and the speaker name is the same one thing, the same search term, again followed by an arbitrary string. Lucene has wildcard support in queries. You can put stars and question marks in there, kind of like DOS command prompt wildcards. So let's take a look at the index, the session search index under models. Here's session search index, and basically all it does extra is just say the title and speaker name fields should have the field indexing analyzed behavior. And this enables me then to do a Lucene query, say the index name. By the way, I could also put it as part of the generic parameter if I wanted to, and then use these title and speaker name fields. And Lucene has a bunch of additional operators, so you can do ands and ors and negate conditions. It's all part of the Lucene syntax. And as for query suggestions, this is another really cool feature. I have here search speakers by term, which uses the query method with the speaker by name index. So let's take a look at speaker by name. Speaker by name is, again, a very simple index that says the name field of a speaker should have this field indexing analyzed behavior. And then when I do the query, I'm looking for speakers whose name is equal to the term, but it only looks like an absolute equality. It doesn't have to be. It's a fuzzy search. And if the query fails, if I'm not getting anything out of the query, I can ask Lucene actually, for suggestions. What should I put there to get results? And that's something the database can do for you at no extra cost. So whenever you execute a query on Lucene analyzed fields, you get suggestions back. Even if the query succeeds, you get suggestions, but I only display suggestions if the query fails. And of course, you can tune this whole thing. You can say how fuzzy you want it to be. And you do have access to the underlying Lucene engine if you want it. But basically, instead of having to integrate another product for full-text search in addition to your DocumentDB, you can just use Lucene, which is there under the covers. I think that's another really nice value proposition. Before we move on to questions, and we still have a little time, I'd like to mention at least a few advanced features and then a few words about RavenDB 3.0, which was just released recently, and then if you have any questions, I'll be happy to answer. So first, there's obviously a bunch of features we haven't covered. So for example, there's batching support for making bulk inserts, for making bulk queries by index, for getting a bunch of data in and out of the database. There is an asynchronous API, which was introduced about 2.5 years ago, I think, which gives you await support. So you can make asynchronous operations against the database. What I showed you were synchronous calls, and you have asynchronous versions using the async session class. You can store files in your database, just blobs, binary objects, instead of JSON documents. It's called attachments. So you can attach a binary file of arbitrary length to your JSON documents. And that's obviously much more efficient than trying to index that thing, trying to treat it like a JSON document. So you can have attachments in your database as well. There's patching support, which I've already mentioned, which means you can ask the server to make a partial update without having to read the whole document and then send the whole document back to the server. There's transaction support, which actually I haven't shown you, but it's pretty nice. The document store, as you recall, is ACID. The document store is transactional, and so you can just start a transaction, insert a few documents, and the whole thing succeeds as a unit and is isolated from other transactions. It's using the standard .NET transaction scope support, so if you do any operations on a session as part of a transaction scope, they will participate in a transaction. What doesn't participate is indexing. Indexes are updated in the background independently of the transaction. But the transaction on the document store, the document changes, additions, deletions, will happen as part of the transaction. A bunch of other features are available. RavenDB.net is your friend. There's a bunch of nice tutorials there as well. In Raven 3.0, there were a bunch of pretty significant changes. First, the Management Studio, this beautiful Silverlight application, has been reworked. It's now an HTML5 app that looks great on iPads and obviously is much more modern. There is a web API infrastructure for the server, so it's no longer using custom HTTP listeners. It's based on web API. Also makes hosting in IIS much easier. There is some work on Linux support, by the way, now that ASP.NET 5 is coming. Raven does not support Linux at this point, but it's definitely the plan to. They are planning to have Linux support pretty much, I hope, pretty much after ASP.NET 5 is finalized. There is now a first-class Java client, again, for Windows only at this point, but it will probably also support other platforms. As part of Raven 3, there is a custom storage engine, which they were previously using Ascent, which ships with Windows. They have now, optionally, a fully managed storage engine written in C#, which in some cases is more efficient than the storage engine they already have. It's pretty much an internal change, which we won't see directly, but it does affect performance occasionally. And there's a bunch of good things on the diagnostics side. So the Management Studio, for example, gives you much more insight now on what's going on with your database, indexing performance, general load, a bunch of really pretty graphs and analytics. So we have some time for questions if you'd like. The slides are available here, and I'll also share on my blog and Twitter in a couple of days the source code if you'd like to review this little ASP.NET application. If you have any questions after the session, then please feel free to send me an email, contact me through Twitter. I'll be happy to help. And now I'll be happy to answer questions, discussion, and drink some water. Yes.
The RavenDB server support clustering.
Okay. Yeah. Does Raven support clustering? What's the multi-server story really? It's not as strong as it could have been. Say Couchbase has a much better story. But there is basic support for sharding and replication. So you can specify how to shard your documents across servers, and you can also set up replication between servers if you want, master. I mean, it works, but it's not automagic. It's not like in Couchbase where you add another server and it sort of just distributes everything magically. You do need to work to make it happen. Yeah.
So what happens when you add a property to your object?
What happens if you what?
Add a property to your object. So you have your objects back to your documents, and then you add a property.
Uh-huh.
Can I still open the existing data using
Yeah.
the object?
If you add a property, it's optional, so you can still read documents that don't have it. Obviously, if it's critical to your business logic, then you'd have to do something about it. But yes, it doesn't break existing documents. It doesn't break existing code. If you make more considerable schema changes, as someone already asked, then you'd probably need to update existing documents, like say splitting a document into two or similar considerable changes. But just adding another optional property is not a breaking change. You can still read existing documents. Yeah.
How would you typically do that data migration? Would you have to create a program to do it, or are there tools that
Which migration?
so if your object structure changed and you want to make more substantial
Okay, yeah. There is no magic tool that will do it. So say Anti-Framework has migration support built in, which is really nice. It's generated automatically. No, Raven doesn't have this kind of good migration story. It requires some code. Yeah.
Is there a in-memory possibility for the...
In memory, there is an embedded client which doesn't require a server, but the database is not in memory. It's stored on disk. There is no memory in-memory only flavor. No. I think, yeah. Yeah, the green one.
If you're relying on the queries that are generated automatically,
If you rely on,
if you're relying on the queries that are generated, or the indexes that are generated automatically, should you be running periodically queries against the agent to make sure that it's still keeping those active, or do you just rely on
yeah, so you're worrying that the indexes might be deleted. So yeah, Raven does have a policy where it will eventually get rid of indexes that aren't used at all. And yeah, you have control over it. So you can configure the database to do it or not do it if you want. If you end up running queries just to keep the index alive, it's not a good sign. You can rather configure the database to not get rid of it. Or just create it manually, explicitly. By the way, you can create indexes from the management studio, so you don't have to write code for that. You can do it through the UI. Yeah.
I was going to ask, is there support for inheritance?
For inheritance. Well, you can definitely say write a class that derives from speaker, and it will be serialized to a document, but there will be no relationship between there will not be a separate speaker document and a separate derived speaker document. So it's just like another class, it's like another entity type. Unlike a SQL database, there is no normalization needed, so you definitely can represent inheritance, but you can't say query speakers and all other classes derived from speakers. There's no such support, for example. Yep.
Is there any limitation on document size?
Are there any limitations on document size? Yes, absolutely. I don't remember the exact numbers. I believe, I really don't recall, but I believe it's megabytes, many megabytes, but not, say, arbitrary size. I also have a vague recollection that it can be tweaked, but I don't recall. We can look at the docs together if you want. Yeah?
I might have missed that, but is there a way to map private properties?
To map what?
To map private properties. So basically, because I saw you didn't do it on your object, you didn't have any annotations of your properties, but they were all public. So what happens when you have private properties?
Yeah, so but again, by default, it does JSON serialization, so it serializes public properties. Yes, you have control over it, so you can ask to alter what goes into the database and what doesn't. I personally am a firm believer that the things you store in the database should be really plain objects with no behavior, what people call data transfer objects. But yeah, you could have complex objects and then complex serialization behavior. Yeah,
You should be able to use non-serializable attribute, isn't it?
it's not the non-serializable attribute, but yeah, you have control over serialization. Yep.
You said that we shouldn't worry so much about denormalization and there being duplication. Is there any magic for that, or do you just have to remember where you've got denormalization and update it?
Is there magic to do what?
To remember the denormalized, the fact that you've got it, you've got values explicitly contained in an object as well as in the other
Well,
object.
Well, you have the profiler to tell you if you're making too many round trips. So, but it's basically, it has to be built on real data. So,
Say you had, so say in your document you had, you knew that you always had, with a contained object, you had the name, but you also wanted to have the ID in order to do other querying. So your name is denormalized into the contained document. If you change the name and the ID, do you have to remember that you denormalized the ID?
that's what you're asking. Yeah. It's an update you have to make yourself. Yeah. So there is no. I mean, you either keep an ID or you keep the whole object, and you have to make the updates. You have to make the updates. Yeah.
Is there something like a backup and restore functionality, or
There is a what?
backup and restore, or are you
Yeah.
just relying on the
Yeah. No, you can absolutely backup and restore. There's also replication support. But yes, there is a built-in backup and restore story which you can automate or you can run manually from the management studio. And the whole database can be exported as a file if you want and imported elsewhere. So yeah, it's a pretty decent story.
How do you state if an object should be stored as a reference or as in the document itself? Where do you state this property to be this option? Is it something like an attribute over the list of the included references?
No, you either store an ID or you store the contained object. It's never a reference. Yeah.
Do you have any statistics about which companies are putting NoSQL databases in production? Is it mostly startups? Or you do?
I gotta say, I probably should have statistics like that, but I have never, I have never tried to kind of build, a marketing talk on why you should be using NoSQL and who's using NoSQL. I bet there are many very big players using NoSQL. I bet every Fortune 500 company has some kind of something using NoSQL. I don't have statistics, but I bet anyone, Raven, Mongo, Couchbase, Neo4j, any NoSQL database will have this on their front page, big font, who the customers are, why you should use their product. I just don't have that,
Do you know what's the most kind of practical use case for this kind of database?
I personally find that it can be used pretty much everywhere. So it's pretty rare that you have the kind of schema that you cannot describe as documents. And modeling is usually pretty easy. So say if you were using a graph database, it really takes a kind of a paradigm shift to start thinking about your stuff as nodes and edges. But documents, they're so much like database rows that it's usually pretty simple to model your, say, SQL stuff as a document. Doing it effectively takes some getting used to. You make mistakes along the way. You change your schema a little. But I don't, seriously, in most of my work now, I don't see a preference. I don't have a preference to SQL unless I'm forced to by, some external factors. Many people prefer SQL because that's what they know. They have resources for, they have DBAs for, they know how to optimize for, and they don't trust, this little company from wherever that builds NoSQL solutions. But, from like the technical side, I think almost everything can be modeled as a document database.
How about performance-wise?
Again, I've shown you a couple of examples where you get much better performance from the background indexing because it's all there when you need it. Conceivably, if you have like totally dynamic queries, like a user is sitting there with a nice console and typing in SQL queries, it will be faster maybe to let them run these queries on a SQL database because you have indexes. You think of indexes in advance and then you execute queries against them. And in Raven, you would have these indexes generated on the fly and linear search first time you run the query. Say, this is a situation where SQL could win. But I mean, for most apps I built have a pretty small set of queries. Small could be hundreds, could be thousands, but it's pretty small. It's not, not every possible combination of fields would be queried. And so once you have indexes for that, it's blazing fast. Mm-hmm.
Do you have support for versioning of documents?
For what?
For versioning of documents or auditing?
Support for versioning. There is support. I'm not sure it's exposed. Documents have e-tags, which is used for HTTP as well. So you get cached versions and so on. I don't recall if it's exposed, if you have direct control over it. I don't remember. We can check.
Say, for example, you make a change to a document and creates another version of it so you can see the history.
Conflict detection or history? No, there isn't history support built in. But there, again, because there are e-tags, you can do conflict detection probably. I'm not sure. I'm sorry, just not sure. Yeah. Mm-hmm.
How easy is to mock the API?
What was that?
How easy is to mock the API? Is it possible to mock the API for example?
Mock the API. Well. Yeah, there's RhinoMox. No, RhinoMox is dead. It's not a serious product anymore. It's not really easy to mock the API. No. I mean, it is factored behind interfaces, but there's a bunch of stuff you'd have to mock. So I think it's easier to use a repository pattern and mock that, not try to mock the database. Mm-hmm. Yes.
SQL Server's got a SQL agent built in where you can run jobs and things overnight.
SQL Server has.
SQL agent built into it, which runs scheduled jobs and all sorts of things.
Mm-hmm.
Does Raven want the same thing?
No, there isn't something like an agent that runs jobs. No.
How do you control security, like who has access to the database?
Right. Who has access to the database? So generally, the deployment recommendation I'm getting a feel for is that the database sits on a server which isn't really accessible from the internet. So you could hypothetically, expose Raven to the internet, but you shouldn't. It's not designed for that. That said, there is support for authorization and authentication. You could have role-based security for users. It's not document-based. I don't recall what's the granularity level, but there is definitely support for access control to the whole database. Yep. All right. Well, enjoy lunch, and thank you very much for coming. Enjoy the rest of the conference. Thank you.